Welcome arithmetic ninjas to subtracting mixed number fractions where borrowing from a whole one is required. Now what this means will become clear as we go on. But before we start, something that is very, very important to this video. We've got to know what a whole one is worth in various fractions. So for example, if you're dealing with quarters, then it would take 4 quarters to be a whole one. If you're dealing with eighths, it would take 8 eighths to be a whole one. If you're dealing with fifths, it would be 5 fifths to be a whole one. If you're dealing with ninths, it would be 9 ninths to be a whole one. Now, the reason why we're talking about that will become clear as we move through the video. So we've got 6 and 3 fifths, subtract 1 and 1 fifth. Now, we don't need a common denominator there because we already got a common denominator. The common denominator is fifths. So we're going to set it up as a column method. So we've got 6 and 3 fifths, take away 1 and 1 fifth. Put some lines there for your answer. And we're just going to do it like a normal column method. Do the fraction part first. 3 fifths take away 1 fifth is like saying 3 apples take away 1 apple, which would be 2 apples. So 3 fifths take away 1 fifth is 2 fifths. And then the whole number part, 6 take away 1 is 5. So your final answer is 5 whole ones and 2 fifths. Not much of a problem so far. Let's have a look at the second one. Again, we've already got a common denominator of 8, so let's set it up as a column method. We've got 8 and 1 eighth, take away 2 whole ones and 7 eighths. Now this one is going to be a little bit trickier. We've got 1 eighth, take away 7 eighths. Now, because the bottom number is bigger, 7 eighths is bigger than 1 eighth, we can't do it. It's like with a normal subtraction. If there's more on the floor, you need to borrow from next door. 1 take away 7 you can't do. You'd have to borrow from next door. So 1 eighth take away 7 eighths you can't do. You'd have to borrow from the next column. So we're going to borrow from 8, and that's going to become 7. But the whole one we've borrowed, because we're dealing with eighths, is 8 eighths. We said that earlier on, that one whole one is 8 eighths. So instead of transferring a whole one, we're going to transfer the 8 eighths onto this 1 eighth here. So if you put the 8 eighths onto 1 eighth, that's going to make it into 9 eighths. 1 eighth plus a whole one is going to be 1 eighth plus 8 eighths, and that's 9 eighths. So we're transferring the whole one that we've just borrowed onto the 1 eighth, so that's going to make it 9 eighths. And now we've got a bigger number on top. 9 eighths take away 7 eighths is 2 eighths. 9 apples take away 7 apples is 2 apples. So 9 eighths take 7 eighths is 2 eighths. And then we can carry on. 7 take away 2 is 5. So the final answer to that question is 5 and 2 eighths. Let's look at question 11. Now the first thing we need is a common denominator. So to get the 4 into an 8, we just need to double it. Times by 2. So if you times the 4 by 2, you get 8. So times the 1 by 2 as well, you're going to get 2. So we're replacing the 1 quarter with 2 eighths. Now we've replaced it, we don't really need the 1 quarter anymore. So we're basically dealing with 7 and 2 eighths. So we've got 7 whole ones and 2 eighths. Take away 4 whole ones and 7 eighths. Let's see where this takes us. So 2 eighths take away 7 eighths, we can't do, so we need to borrow. Borrow from the 7, and that becomes a 6. And the 1 whole one that we've borrowed is worth 8 eighths. So we're going to transfer 8 eighths onto this 2 eighths. And 8 eighths onto the 2 eighths is going to make 10 eighths. So cross out the 2 and make that a 10. We're now dealing with 10 eighths. 10 eighths take away 7 eighths is 3 eighths. Because 10 take away 7 is 3. And 6 take away 4 is 2. Final answer, 2 whole ones and 3 eighths. Now for question 14. Again, we need a common denominator. Is there an easy way we can get the 2 into an 8? Yes, there is. We can times the 2 by 4. So 2 times by 4 is going to give us 8. And 1 times by 4 is going to give us 4. So we're dealing with 1 and 4 eighths. Now we're dealing with 1 and 4 eighths. We can scribble out the original half because we don't need both of those. And we can now do our column method. So it's 4 and 3/8, take away 1 and 4/8. Again, the bottom fraction is bigger, so we can't do it. 3/8 take away 4/8 we can't do, we've got to borrow. In the same way that in a normal subtraction, 3 take away 4 we can't do, we've got to borrow. So 3/8 take away 4/8 we can't do. We're going to borrow from the 4, and that's going to become a 3. But the whole one we've just borrowed, and this is the most difficult bit, the whole one we've just borrowed, we're dealing with eighths. So the whole one we've just borrowed is 8/8. And we need to transfer that 8/8 onto the 3/8. Well, 8/8 on top of 3/8 is going to be 11/8. So the 3/8 has now become 11/8. 11/8 take away 4/8 is 7/8. 11/8 take away 4/8 is 7/8. So 7/8 goes in there. And then we've got the whole numbers. 3 take away 1 is 2. Final answer, 2 and 7/8. For the last question, we've got ninths and thirds. So is there an easy thing we can do to thirds to get into ninths? Yes, there is. If we triple the 3, we're going to get 9. That's what we want. So we need to triple the 2. So we're going to get 6. So the 2/3 becomes 6/9. Scribble out the 2/3, we don't need that anymore. We're dealing with 6/9 now, equivalent fraction. And now set it up in a column method. So we've got 7 and 4/9, take away 5 and 6/9. So 4/9 take away 6/9 we can't do, in the same way that 4 take away 6 we can't do. We'd have to borrow from the next column. Borrow from the 7, that becomes a 6. But the whole one that we've borrowed, and this is the hardest bit, the whole one we borrowed, because we're dealing with ninths, is 9/9. And that 9/9 that we borrowed is transferring onto the 4/9. Well, 4/9 and 9/9 makes 13/9. Because 4 plus 9 makes 13. So scribble out the 4/9, and we're now dealing with 13/9. And now we can carry on. 13/9 take away 6/9 is 7/9, in the same way that 13 apples take away 6 apples is 7 apples. And 6 take away 5 is 1. So your final answer is 1 whole 1 and 7/9. Now this is going to be one of the hardest questions on the entire arithmetic paper. So you're doing really well if you can get your head around this one. But just remember that it all boils down to this bit that we talked about earlier. A whole 1, if you're dealing with quarters, is 4/4. A whole 1 with 8s is 8/8. A whole 1 with 9s is 9/9. And when you borrow from the units column, from the whole number column, you're just transferring a whole 1, whatever that whole 1 is worth, into the fraction column. Anyway, now we've had a go at 5 questions, it's time for you to have a go. Good luck.